Hello students, welcome back to A-Star Tuition channel. Today we'll discuss dot factors, one of the basic concepts in physics. Let's start. In physics, we deal a lot with quantities, and there are two types of quantities that you need to be aware of. The first one is called factor quantities, and the second is scalar quantity. Now, what is the difference between factor and scalar? Now, factor is a quantity that is described by its magnitude as well as direction. Scalar quantity is a quantity that is described only by its magnitude. Now let's list some of example of factor quantity and scalar quantity in physics. Now, example of factor quantity is displacement, because we need to know the amount of the change in position as well as the direction. There's also velocity, force, momentum, electric field, and there are actually many more, but these are some of the lists for a factor quantity. Scalar is a quantity that is described only by magnitude. Example is just distance, for instance. The speed, pressure, as well as example temperature. So these are quantities that we do not need to describe the direction, because there is no direction, so only magnitude. Now, in some cases, you have a situation when there are two factor quantities that you want to combine. Now, we usually use like a straight line with an arrow to denote a factor. So let's say this is a force factor, F1. Now you see that I use a arrowhead above the letter to describe a factor. So you have a factor F1, and then you also have another factor F2. Now, what is factor F1 plus F2? So in this case, what you need to do to combine the factor is to find the resultant factor. The resultant factor is obtained, you can obtain by several methods. One of the methods is simply graphical. So the way it works is like this. So first you draw the first factor, F1, and then right on the tip of F1, you draw the tail of the second factor. So you can just displace this factor F2 here. Make sure that the length doesn't change, the direction also doesn't change, like that. F2. So the resultant of F1 plus F2 is obtained by drawing a straight line starting from the tail of the first factor to the tip of the last factor. So this and that straight line. So this is the resultant, which is F1 plus F2. Now you can use this method to add not only two factors, but as many factors as you want. Now, for the example of three factors, let's say F1 plus F2 plus F3. Now, in this case, let's use this example. And let's say this is F1, F2, then F3. Yeah. So by repeating the method earlier. So first you draw the first factor, which is f1, and then on the tip of f1 you draw the tail of f2, right on the point. Okay, so this is f2. Then on the tip of f2 you draw the tail of f3, like this. Yeah, so more or less like this. So then we draw a line from the tip, from the tail of f1 to the tip of f3, straight line, like this, and this should give you the resultant f1 plus f2 plus f3. Yeah, so this blue line segment is the resultant. Now you can see from this method that in order to improve the accuracy, you would need to draw this in a grid paper. Yeah, because otherwise the drawing would be maybe, very not accurate. Yeah, so the best way to draw this to find the resultant factor using graphical method is doing it on a grid paper and use some tool, yeah, like ruler. Yeah. What about subtraction of two factors? Like, what happens if you have f1 and you want to do minus f2? Now, if f1 is, let's say this is f1 and this is f2. Now, f1 minus f2 can be understood as f1 plus minus of f2. So if f1 is drawn like this, yeah, okay, then f2 is drawn exactly like this, but instead of directed downward, it's actually directed upward. Yeah, so like this. Okay, so this is minus f2. Again, you put the tip, you put the tail of minus f2 on the tip of f1, and then you draw a straight line, yeah, joining the tail of f1 with the tip of f2. That gives you the resultant, which is f1, which is f1 minus f2. Now again, it would be much easier to do this using ruler and on a grid paper. So this is f1 minus f2. Now what if you want to add like multiple of factors, like what I mean, 2f1 plus 3f2 minus 2f3, for instance. Now what you need to understand is that 2f1 meaning that you have a factor that is in the same direction as f1 but twice the magnitude, whereas 3f2 is simply factor that's in the same direction as f2 but 3 times the magnitude, and minus 2f3 is a factor that is in the opposite direction of f3 but that the magnitude is twice of f3. So if you are given the factors, what you need to do is you need to scale each by the coefficient here, and then for f3 not only you scale it by scale f3 with twice magnitude, but also the direction need to be flipped. Yeah. So example is this. This is again f1, and let's say this is f2. And then let's say f3 look like this. Yeah. Now let's add these 3 factors, 2f1 plus 3f2 minus 2f3. So 2f1 meaning that the factor is twice the magnitude of f1 but in the same direction. So let's draw it like this. So this is 2f1 and then 3f2. So mean that you draw this, remember you put the tail of f2 on the tip of f1, but draw it 3 times. Yeah? So more or less like this. This is 3f2 and then you have f3, but this is minus 2f3, so twice the magnitude but in the opposite direction. So more or less like this. Yeah. Okay, so this is supposed to be a straight line. Yeah. So this is 2f3. So now that you have minus 2f3, so once that you have this, again we need to draw a line between the tail of the first factor to the tip of the final one. So draw a straight line. And so this, the direction is from the tail to the tip. Yeah. Okay. So this factor is 2f1 plus 3f2 minus 2f3. Now, when you try to find resultants of 2 or more factors, the method that we explored earlier, which is by graphing, that's not actually the most accurate method to find the resultant, because it depends on how you draw it. Yeah. There is a more accurate or more actually commonplace method to do that. We call that method as this resolving factors. So in order to understand the idea of resolving vectors, let's give an example. Okay, let's say that a person is walking from A to B. Now, this is a straight line motion, but you can see that the motion can be understood as a sideways or horizontal motion and also vertical motion concurrently, which means that it happened at the same time. So you can actually resolve the displacement AB using this. So you just do a projection of this line with respect to horizontal, and this is what you're gonna get. Yeah, this is the horizontal component. Yeah. Now B from here, this is the vertical component. Now the horizontal and vertical component also have direction. The direction for the horizontal is this, and for vertical is upward, like that. So rather than moving from A to B directly, you can understand this displacement as the addition of the component, the horizontal component, and add with the vertical component. Now, so these are we can say that these are the components of the factor AB. So in order to do that, we need to use trigonometry, basic trigonometry, to find the horizontal and the vertical component. Now, if you remember, if you have a triangle, a right angle triangle, and there's an angle alpha between the two sides, between the adjacent and the hypotenuse. Let's say that this is the quantity. Let's say this is Q. Now Q has horizontal component as well as vertical component. The magnitude of the horizontal component, we call it Qx, Q sub x, and the vertical component is Q sub y. Now if you remember SOHCAHTOA, Q sub x over Q is equal to adjacent over hypotenuse, which is cosine alpha. So from here, Qx would be Q cos alpha. And for the vertical component, if we do ratio of the vertical component, which is actually the opposite side with the hypotenuse, we'll get sine alpha. So then the qy would be q sine alpha. So this is how you resolve the factor, yeah, into vertical component as well as horizontal component. Now let's look at an example how to add factors by resolving into components. Okay, so let's say that here I draw the three factors. Yeah, there are three factors. This is the first factor, f1. Okay, and this is the angle theta 1. So this is the angle formed by factor f1 with respect to the positive horizontal axis. Okay, so the horizontal axis is x and the vertical axis is y. And then let's say that there's another factor this way. F2, yeah. F2 is, let's say, this is F2, and it also forms an angle, but this time with respect to negative horizontal axis, theta 2. And then you have the third factor, let's say this one. This is F3. Okay? Now F3 is horizontally downward. I mean vertically downward. Yeah. So there is no angle. Well, the angle is 90 degrees with respect to either positive or negative horizontal axis. Okay. Now, in order to find the resultant by resolving, what we can do here is we find the horizontal component of each factor and then we add them all together. Now in this case, let's look at F1. Now F1 has a horizontal component which is given by magnitude F1 cos theta 1. Okay? Whereas F2, if you resolve horizontally, it will have a magnitude of F2 cos theta 2. Okay? So when we try to find the sum of the horizontal component of all factors, we'll wind up with F1 cos theta 1 minus F2 cos theta 2. Now, why minus? Because when you resolve F2 horizontally, you can see that that arrow is actually pointing this way, to the left. So remember, imagine that you can rotate this factor and you find the horizontal component. You see that the arrow is, the tip of the factor is pointing to the left. So that's why it's negative there. Now as for F3, because this is totally vertical, it doesn't have any horizontal component, so then we don't add anything to sigma fx. Okay. Next is sigma fy, which is the sum of all vertical components of the forces. Now F1, you can see here that the vertical component, if you resolve it, it's F1 sine theta 1. Now F2 also, if you resolve it vertically, it's it's F2 sine theta 2. And as you can see here, if you resolve F2 vertically, the tip of the factor is pointing upward, so it's positive. The same goes for F1. So then you add the two. So F1 sine theta 1 plus F2 sine theta 2. However, for F3, this is vertically downward. So you need to subtract this from, you need to subtract F3 from these two. So this is going to give you resultant, the sum of all vertical components of the factors. Now that we have sigma fx and sigma fy, we can actually calculate the resultant by taking the square root of the sum of the square. So square root of the sum of the square. And the way it works is like, if you're familiar with Pythagoras theorem, you always use this Pythagoras theorem for two, when you have a triangle, right angle triangle, if one of the side is A and the other side is B and they're perpendicular, then you can find the hypotenuse by using the Pythagoras theorem. And this is exactly that, because as I mentioned, the sum of all horizontal component is perpendicular to the sum of all vertical component. Yeah. Now, once you have this, you can also find the direction. And as always, we use angle to describe direction. So tan of alpha equal to sigma of fy over sigma of fx. So use absolute value. Now once you get alpha, what you need to do is you need to determine whether sigma y positive or negative, or whether sigma fx positive or negative. Now, because it will determine the quadrant that the resultant factor belongs. Okay, so if the sigma fx positive, sigma fy positive, then we know that the resultant factor belongs in the first quadrant. So the angle, we can write it as alpha, so whatever alpha is. But if the sigma fx is negative while sigma fy positive, then we know that the resultant factor lies on the second quadrant, yeah, and the theta is 180 minus alpha. Okay, so whatever alpha you calculate, you just subtract alpha from 180, will give you the angle. Yeah. Now this angle is measured with respect to positive horizontal axis, yeah, and going counterclockwise. Okay. Now, if sigma fx and sigma fy both negative, then we know that the resultant factor lies in quadrant 3. Theta is equal to 180 degree plus alpha. And last, when sigma fx positive, but sigma fy negative, then the theta is equal to 360 degree minus alpha, or you can just write down as minus alpha, because you know that 360 degree is also equivalent to 0 degree. Yeah? So hopefully you get a sense of how to add these three factors by using resolving into components. Yeah? Okay. Next, let's discuss about what happens if we have a factor quantity that changes with time, and we want to find, or we want to quantify that change. Now, let me give you this example. Yeah? So I know that we haven't learned about circular motion, but what the example that I'm setting up today will not make use of aspect of circular motion that is that is not taught before. Yeah? So this should be something straightforward. Now imagine that you have a particle that is moving in a circular motion uniformly. What I mean is that it has a constant speed. So let's say that this circular motion has a period. I mean, the object is undergoing circular motion with a period of t, and t could be any number. Yeah, you could just say 5 seconds. Yeah. Now, at one point, let's say that the particle is moving counterclockwise. Now, at one point, the particle is at this position, and then at another point, let's say the particle is at this position. Now, what is the velocity factor? Now, the velocity factor is always tangent to the path, and the path is circular. And because the motion is counterclockwise, then we can say that the velocity vector can be drawn from like this, tangent to the path and going this way. So this is the velocity initial. Now let's say that it has a velocity of, it has a speed of 10 meters per second. Yeah. Okay, so this is at one instant when the particle is at this position. Now later the particle will be at this position. What is the velocity vector? Well, the velocity vector is also again tangent to the path at that point, and because it's going counterclockwise, you can draw this as the velocity vector. Yeah. Now one thing to note is that since this is a uniform circular motion, then the speed is constant. Yeah, it does not change. So therefore the length of this vector Vf should be equal to the length of the initial vector, the initial velocity vector. Now, but they are not the same vector, by the way, yeah? Because remember, a vector is described by not only magnitude but direction. So even though the magnitude doesn't change, but direction-wise, it still changes. Yeah? Usually, we are asked to find the average acceleration. Now, we haven't discussed about average acceleration. That will be covered in kinematics. But let me just define it like this. Yeah. So I'm just gonna define it, and let's discuss about this further in the kinematics video. So an average acceleration is defined as the change in the velocity vector over time. So basically, you want to find what is the change in the acceleration, the velocity vector, divided by the time. Yeah, it takes from this position to this position. Now, and let's just calculate the magnitude only. Yeah, let's calculate the magnitude only. Although, as you can see later, we can actually find the direction. Now, the thing is this: some misconceptions that, oh yeah, the velocity doesn't change, right? The speed is 10. So 10 minus 10. Now, what is the time? The time is equal to, well, this is like a quarter of a circle. So the time here would be from this position to this position. The time would be a quarter of a period, which is 1.25 seconds. Yeah, or you can write in fractional form, 5/4 seconds. Now, as I mentioned earlier, students tend to misunderstand this as, oh, the speed is still 10, so just do 10 minus 10 over 5/4. Now, this is actually not correct. Yeah? The reason why this is not correct is that here, this is the notion of the change in velocity vector, not the change in speed. Now, the speed doesn't change, obviously, it's 10. Yeah? But the velocity, as you can see, the velocity vector changes from the initial velocity vector to final. So in order to find the change in the velocity vector, what we need to do is we need to do v final minus v initial. Yeah. So what is v final? What is v initial? You subtract. So now, in order to do this, yeah, you can do that by adding factors vf. You can add factor vf with negative of factor vi. Yeah, so as we discussed this before, you can always interpret subtraction of factor as addition of the negative of the second factor. Yeah, so graphically, remember, vf is it's upward like this. Yeah, and then on the tip of factor vf, we need to draw factor minus vi. Now, vi is going this way to the right, so minus vi is to the left. Yeah, so let's draw minus vi here. This is Vf plus minus Vi. Now make sure that you draw the length of these two factors the same length and same magnitude. So then the resultant would be simply a factor that you can you draw from the tail of the first factor to the tip of the second factor. Yeah, so then you can see that the resultant is going this way. Yeah, so this is the resultant, which is equal to Vf minus Vi, which is equal to delta V, the change in the velocity factor. Yeah, so this is that minus Vi. Okay. Yeah. Now you can see that the direction is northwest. Yeah, northwest. The reason is because this is Vf and Vi. I mean Vf and minus Vi both have the same magnitude. So then this angle is exactly 45 degrees. So the resultant is 45 degrees from north to east. So then it's northeast. Yeah, northwest. From north to west, northwest. Yeah, 45 degrees. Okay, so what about the magnitude though? The magnitude is this. Now we know that the magnitude of Vf is 10. So then imagine you have this triangle. Okay, this is 10 and this is 10. Yeah. This is 10 and this is 10. Then you can find the hypotenuse by using the Pythagoras theorem. So 10 square plus 10 square. Square root of that, this gives you 10 root 2 meter per second. So then the magnitude of the change in velocity is 10 root 2 meter per second, and then we can calculate the average acceleration, the magnitude of the average acceleration to be 10 root 2 divided by 5/4, and this will give you 8 root 2 meter per square second. And you can also mention that the direction is northwest. Direction northwest. Or you can say it's, because this is in quadrant 2, it's, equal to 180 minus 45, which is equal to 135 degrees. Yeah. Okay, this is the notion of the change in factor quantity. Another concept that I want to discuss is what we call as the notion of relative velocity. So what is relative velocity? So let me set up this. Yeah. Imagine that there are two objects. Let's call it A and B. A is moving to the right with speed of 3 meters per second, and B is moving also to the right but with the speed of 7 meters per second. Okay, now there's a person sitting here on the ground, stationary. Now according to that person here at the origin, the velocity of A with respect to the person is 3 meters per second to the right, and the velocity of B with respect to this person that is at rest is 7 meters per second to the right. But what about the velocity of B according to A, or vice versa? Now here's the thing, A is not stationary. A is actually moving with respect to rest frame, and B is also moving. Now, B, according to O, B is actually moving quite fast with 7 meters per second. But according to A, B doesn't travel as much as what the person in the rest frame think. So that means there is a notion of relative velocity, because there is a relative motion between B and A. Now, we can actually easily find this by doing this. Let's say we want to find the relative velocity of B with respect to A. So let me write down relative velocity of B with respect to A. Yeah. So this can be found by simply VB minus VA. So you need to subtract factor A from B, or in other words, you add the negative of factor A with factor B. So VB plus minus VA. Now this is easily done because remember these two factors are actually collinear in the same line. Now we can find VB plus minus VA by the graphical method that we studied earlier. Now let's say this is VB. It has a length of 7 meters per second. Now what you need to do is you need to add factor minus VA. You need to put the tail of minus VA and to the tip of VB. But the thing is that if it's not going to be practical if we do this here, so then let's just draw it just below it. So this is minus VA. Yeah. So this is minus VA. And so, but you need to assume that what we're doing here is minus VA is actually the tail of minus VA overlaps with the tip of VB. Yeah. Again, the separation is so that you can see it clearly. Now, so then to find the resultant, which is VB plus minus of VA, you draw a factor. You draw a line from the tail of VB to the tip of minus VA. Yeah, so it's like from here to here. Yeah. So this is VB minus VA. Now you can see that the magnitude can be found easily by subtracting 3 from 7. So VB minus VA has a magnitude of 7 minus 3, which is 4 meters per second. And we can say that this VB minus VA has a direction to the right. So according to A, B is moving with 4 meters per second to the right. Now, what about the relative velocity of A with respect to B? So this is simply the opposite of that. So VA minus VB. Yeah. Now what you can do is that if you want to make use of what we draw here, this is just a minus of VB minus VA. And we already know VB minus VA is this factor. So then minus of that means that you just need to draw VB minus VA factor, but then draw it in the opposite direction. And that the magnitude is still the same, yeah? So the magnitude is equal to 4 meters per second, but this time it's moving to the left. What if the two velocity factors are not collinear? So in other words, this is VB and this is VA. Now in this case, you can just find the resultant, which is still, if you want to find the relative velocity of B with respect to A, you still need to do this, VB minus VA, which is equal to VB plus minus VA. And then from here, we proceed with the method that we discussed regarding adding factors graphically, which is, let's start with VB first. So let's say VB is like this. Let me redraw it here, VB. Yeah. And then you need to put the tail of minus VA. Well, remember VA is going this way, so minus VA would be exactly opposite of VA. Yeah. So that in this case, let me redraw VB. Let's say VB is this. Yeah, this is more or less the same. Yeah. Parallel. Let's say this is VB. Okay, and minus VA would be this. Then what you need to do is you need to put the the tail of minus VA to the tip of VB. So like this. Now this is minus VA. Yeah, again, when you deal with graphical method to solve factors, to find the resultant of factor, it is always good if you have, like, measuring device like a ruler, yeah. And also you probably want to draw it using a grid paper. Now VB is this, minus V is that. So then the resultant is you draw a straight line from the tail of the first factor to the tip of the last. So this would be, let me use different color. So this is going to be, okay, so this is VB minus VA. So this is the relative velocity of B with respect to A. Yeah, so this is the relative velocity of B with respect to A. Yeah, and you can actually find the magnitude by using, triangle formula. So if you know the magnitude of VB and you know the magnitude of VA, then if the angle is given, then you can manipulate, yeah, to find the resultant. Also, you can find the resultant by the method that we discussed previously, which is resolving the components. Okay, I hope this video helps you in understanding the basic of factors in physics, how to add factors by using the graphical method, as well as the resolving the components, and the concept of relative velocity and change in quantity. Please like, comment, and subscribe to the channel. I'll see you again in the next video.